So, which is a pair of isomers? Okay, this is a fun question. Okay, there we go. And they give us one butene, so it looks like this. Okay, and 2 methyl propane, so it looks like this. Propane 2. Okay, so isomers, okay, are going to be the different types. Okay, there's constitutional isomers which have the same formula but different equation. Same formula but different composition. Like they just look completely different. And there's different types of structural isomers, and those ones, depending on the chirality in terms of the shape, those ones can end up being like enantiomers or diastereomers, or they're literally just the same compound. So that's what we're dealing with here. So 1 butene and 2 methyl propane. We have to find out first if it's even a constitutional isomer. So 1 butene is actually going to be 1, 2, 3, 4. So that's C4, and then hydrogens 1, 2, 3, 4, 5, 6, 7, 8. C4, H8. That's what we get. And now 2 methyl propane, 1, 2, 3, 4. Also 4 carbons. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4, H10. These are not pairs of isomers. Okay, so the first one, not it. Okay, I'm just putting a box around it to separate between each one, but no, I'm gonna put that X in red so that way we make sure. Okay, so now let's move on. Well, actually, before we move on, I hope you understand how I counted the hydrogens. Is that, if there's no bonds with it, it usually has 3 at the end and 2 when it comes to the middle parts, and then you subtract 1 for every bond. So here it had that methyl sticking out, so it only could have 1 more hydrogen. And here there is a double bond, so you kind of just subtract it. So instead of 3, it would be 2. Instead of 2 here, it was 1. Okay, so now H2NCH2CH3. So it kind of looks like this, but it has an N like that, but it has an N H2 at the end, and then it's compared to NH2. So you might already start to notice, but these might in fact be exactly the same. So we have 2 carbons, C2, 1 N. Well, we can put that in the end. We just got the H's first. 1, 2, 3, 4, 5, 6, 7. So it's C2H7N, and this one C2H7N. And based on this picture, you can kind of just say that these are literally the same compound. These don't count as isomers because they're exactly the same thing, just flipped over. Okay, so that's not it either. Now we have CH3O, so it looks like that, like this. And then we have, oh no, I skipped one, propanol and ethene. So we have propanol and ethene. Literally already you can see that they're quite different. So this one is going to be no, because propanol, in fact, just for fun, that's C2H4, and this is 6, 7, 8. So that's C3H8O. That's what that is. And so that's definitely not even close to each other at all. CH3CH2OH. So we have this now versus CH3O CH2CH3. So these ones, always good to check again. So they have 2 carbons, C2, 1, 2, 3, 4, 5, 6, H6, okay, and then, oh, and this one has 1, 2, 3, 4, 5, 6, 7, 8, so C, and it has 1, 2, 3 carbons, H8O, and these are definitely not the same thing, so they're not even isomers, they're not even constitutional isomers or anything, they're not the same compounds. So now we have this one, CH, so the last ones that we were discussing here are 1, 2, 3, 4, 5 carbons. It just helps me draw it. So it looks like this. Oops, that's 6, 3, 4. Yeah, there we go, 5 carbons versus 1, 2, 3. And when it has that commas like that, it means that it branched out. So that's what they're trying to imply. Okay, so we have these two compete with each other. Okay, so now we have, let's count the carbons, 1, 2, 3, 4, 5, C5, okay, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, H12, okay, 1, 2, 3, 4, 5, C5, cool, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So this actually is the only isomer here because it has the same constituents. So let's see, and that is correct. So these are constitutional isomers. These are the only pair of isomers because remember, this is actually the most important one. Same does not count. If it's the exact same structure, like as in they're the same thing but just rotated, that is not an isomer. That's just the same compound. Okay, so now let's move on to question 7.